So now the topic here is three-phase semiconductor fed separate accelerated DC motor. See, last class we have seen the single phase semiconductor and single phase full converter for both separate accelerated DC motor and series accelerated DC motor. This time we will go for the three-phase semiconductor and three-phase full converter, and once again for both separate accelerated DC motor and um, series DC series motor. So for both the cases we'll do this as it is as this is three phase. So I have tried here the three phase voltage waveforms RGB is the phase sequence here. Okay, RGB is the phase sequence. I will write here the phase sequence is RGB. Okay, uh, see ABC he has given. Okay, you can take it as ABC only. So this is A, this is B, this is C. You can take like this. Okay, or you can take RGB also. No problem. There is no problem here. Okay. So what are the voltages here? Voltage in the sense I will write here VAN. New see phase voltage of phase A is VM sin omega t. VBN is equal to VM sin omega t minus 120. So VCN is equal to VM sin omega t plus 120. So what you need to understand here is that see, so there's a three-phase semiconductor. So as you have three-phase semiconductor, out of six switches, three switches are thyristors, and the remaining three switches are diodes. So I have given the numbering also. Then you have a freewheeling diode here. Then that output voltage is going to a this is R, this is RA, LA, and the EMF here is EB. Okay, this is common for the separate accelerated DC motor, like you have seen in the previous classes also. Okay, so what you find out here is that if you recall carefully now, that which set of thyristors you will turn on first and how you go ahead is a little bit thing to understand. To understand this, what you need to do here is that see this logic, everyone, I'm sure that you know this logic. So this intersection, this red and blue intersection is 30. Okay, so I'm sure it is 30. That you can check yourself if you want. And similarly, this intersection between red and green is 150. Whereas, yeah, this intersection between uh, green and blue is how much? This intersection is how much it is? So 90. Yeah, it is 90. So this is 90. 90. So on this intersection is 210, and this intersection, yeah, I'm just writing only the inter 270. Now this intersection 330, and this intersection this intersection is 390. This intersection is 450. Okay, so whereas this intersection is 510. బౌ ల్యాబ్లో సైన్ చేయించుకున్నా. So So now you see here, let me check now. Okay. So what you will understand here is that I hope you know this thing that that this A phase is having higher voltage compared with B and C from 30 to 150. So it means one thing you can say this thing that the thyristor which is connected to A phase directly, that is thyristor number 1. You see the circuit diagram here. So this thyristor number 1, you can you can turn on. You can turn on. So when it will be on in the sense. So once again, it depends upon which other voltage is there. It is left. So for example, if it is one is on, then what about B and C? So among B and C, which one is higher once again? So likewise, you just cross check and if you cross check and you will find out this thing that uh, the voltages you will get simultaneously. Okay. So assume that right now the firing angle of for all the thyristors is alpha is equal to 0. Say for example, alpha is equal to 0. This is one condition you will take. Then what is VA? The output of semiconductor. So the VA will be something okay, important, some important thing you will understand here for VA. So what you will observe is that a simple thing you will understand here. Okay. So what you will find out here is that, so this is 30 to 90. 30 to 90, we can take one duration. So why we will take one duration is that, first I will see here one thing I will do now. Okay. 30 to 90. 30 to 90, what you find out is that VA is greater than VB and VC. And now which voltage is higher comparatively that so you see this waveform, VB is greater than VC. This also you can understand yourself. Okay. So because there is a negative voltage. So which is more negative here in this case? Which is more negative in this case is that, if you see carefully, this green is more negative. So when green is more negative, that's the reason that I put VB greater than VC. So it means out of all the three, VA, VB, VC, highest is VBA and lowest is, you see here, VB is greater than, sorry, VC is greater than VB. Okay. Just see yourself that between 30 to 90, just check between 30 to 90, what you will find out is that between 30 to 90, one thing you will understand, VA is greater than VB, VC, both. And VB is VC is greater than, so I will write this better than rather than writing like this. I will write this sequence. Yeah, I will write the sequence here that. So I will write in the descending order. Yeah, how to write in the descending order is that VA greater than VA greater than VC greater than VB. I will write like this. So VA greater than VC. So the highest is VA, whereas the lowest is VB. Okay. So if that is the case, then in that case, say for example, it is always suggestible. See, A is connected here at 1, B is connected to 2, C is connected to 3. So I hope you remember this thing that the operation of the semiconductor or full converter, you have 6 set of you have 6 switches. Out of 6 switches, only 2 will be turned on at a time. One from the top leg, another from the bottom leg. The top leg are thyristors, the bottom are diodes. So out of 1, 2, 3 thyristors, only one thyristors will be turned on. Okay. So out of 1, 2, 3, which will be turned on is that one will be turned on. Why one is turned on? Because 1 to 1 phase A is connected. So here phase A voltage is higher. So one is turned on. So if one is turned on, then you have some options now. What are the options now? In the bottom leg, you have 3 diodes, 1, 2, 3 diodes are there. Out of these 3 diodes, one diode will be turned on. So we have to identify which diode it will be. And first of all, this thing is that the diode 1 cannot be turned on, because if the diode 1 is turned on, then both the switches in the same leg will be turned on. This is not possible, that you have seen in the operation of your full converter or the semiconductor. So one will not be turned on. So either diode 2 is turned on or diode 3 is turned on. See here, I will write better. I will write for this case that. So in this situation, what you will find out is that, so thyristor 1, so I will let T1 is on. T1 is, so you can turn on. See, T1 is on, this means you can turn on T1. So if you turn on T1, okay, then why it is so? Because VA is highest one. So as VA is highest one, so for the phase voltage A, thyristor 1 is connected. And so out of 3 diodes, 1, 2, 3 diodes, diode D1 cannot be turned on. Why diode D1 cannot be turned on? Because so D1 cannot turn on. Then you have only 2 options, either D2 or D3. So which one is true is, we'll see now. For example, you assume that D2 is on. Okay, D3 is on. If D3 is on, then what do you find out now? So you will find out that the voltage here is C. Okay, so whereas, so this voltage is C, so phase C voltage. So if you think that 3 is on, that's what I'm guessing now. If you think 3 is on, it means the cathode voltage of 3 is C. So this is C, this is B. So cathode voltage of D3 is C. So the anode is also C. If the anode is C, then anode of 2 is also C. So if the anode of 2 is C, whereas the cathode is B, you have seen yourself that VC is greater than VB, so 2 will also be turned on. So then you will face a problem. So our assumption that the diode D3 on is wrong. So what is the only option here is left is that diode D2 will be on. So this is a trial and error method. So D2 is on. So from 30 to 90 degrees, what you will find out is that T1 and D2 are on. This you will find out. Okay, it's very important to understand this logic here. Okay, so from which to which, from 30 to 90, T1 is on because VA is higher among all the 3. So T1 is on. Now among the bottom leg, that is D1, D2, D3, D1 cannot be turned on because it is exactly below T1. So now you have the option either 2 or 3. So if you assume 3 is on, then it is forcing 2 also on. So if 2 is on once again, then B is there here, then 3 will be turned off. So only one option is left here. So not all the, every time either one switch in the top leg and one switch in the bottom leg will be turned on. So not more than that. So one thyristor 1 is on. So among D1, D2, D3, diode D2 will be on because D1 cannot be turned on. And if you think D3 is on, then it shows that D2 is also on. So which is not correct. So the answer is that T1, D2 is on. So if T1, D2 is on, so it means yeah, T1 it has a potential A, whereas D2 it has a potential B. Then the voltage across here, will be A and B. This you will find out. So the voltage across the load is VAB. This you will understand. Okay. So in that case, what do you find out is that, what you will find out here is that so between 30 to 90, I will draw here 30 to 90 exactly. So I will try to draw the 30 to 90 exactly here. So this is 30. Whereas this is 90. So for this duration, the voltage, that is I will write here 30. For the first time I will do all these things. So the next thing you can do yourself, that this is 30, this is 90. So between 30 to 90, the voltage across the motor is VAB because T1, D2 are on. Then what you will find out is that VAB. So what is VAB? VAN is sinusoidal voltage, VBN is also sinusoidal voltage. So difference of these two, that is VAN minus VBN. So when you do VAN minus VBN, okay, what do you find out here? It's a line voltage. So VAN minus VBN is nothing but the line voltage VAB. So what is the line voltage here? That you might have know yourself in the previous three phase analysis that. So it is also a sinusoidal. So it is a sinusoidal. Then you will find out this thing. Okay. So then yeah, VAB. So VAB, I will use VAB as a red color. Anyhow, I will this you will find out. Okay. So 30 to 90 VAB, I will write here myself. I will write here VAB. It is VAB. The next duration is 90 to 150, another 60. So in 90 to 150, if you see once again, VA is higher, but this time the lowest one is VC. So only thing is that in every duration you have to do one thing, that out of three, which is highest and which is lowest. So for 30 to 90, highest is A and lowest is B. So the line voltage is VAB. Similarly, from 90 to 150, next to duration 90 to 150. Okay. So next to duration 90 to 150, the highest is A and the lowest is C. So this time you will get VAC. So it is VAC. Yeah, we'll write here it is VAC. Huh? So now you see here, so we got VAC. So only thing is that what you have to find out here, I will tell you the logic here, that out of, so for every 60 degrees, you will find out this difference. So from 30 to 90, it is 160. So first 60 and 90 to 150. So how, when you draw this, what is the simple logic is that? What is the simple logic is that? So in this duration, one will be always higher, the one other will be lowest. So out of these three, so for example, if you take 150 to 210, in this 60 duration, the highest one is green color. See, the green color is top. So which is that bottom color now? Which is the bottom one? So blue color is the bottom. So what is the blue color? C is the blue color. So whereas the topper is B. So BC. So you will find out BC. So BC is the next one. So likewise, you can complete yourself that. Yeah, we'll just try to complete all this. Then 270 to 330. So likewise, for every 60-degree duration, so you will get this thing. So, but I will give the numbering here. So similarly here also. So now the names here. So here in this case, it is VBC. Whereas this case, the highest is B, lowest is A. So VBA. So likewise, you can, so this is VCA. This is VCB, and this is once again VAB, and so the cycle repeats. You see now. So this is VCB. So likewise you will write. So remember, this is for alpha is equal to 0 degrees. This is how you got for alpha is equal to 0 degrees. For example, if you so if you one thing I will tell you that if the alpha is not 0, if the alpha is more than 0, say for example, just I will take alpha itself. I will just take alpha itself. So in that case, what do you find out is that just see the small difference. Okay. So the small difference I will show you now here. Yeah, we'll just copy this one. Then yeah, remaining all the things I will erase. I just want to show you that when alpha is greater than 0, how the waveform varies. That's what exactly I'm trying now. Okay. So that part will remain as it is. Only thing is that, see, when I increase alpha value greater than 0, in that case, how the waveform will vary, that will show. Now you see here now. See, as alpha is greater than 0, so the triggering, earlier the triggering happens here, exactly at 0, in the sense the triggering will happen here at this point. Okay, at this point, at this point. Yeah, better I will write here VAB in the sense which one, T1, D2. Better I will write. So VAC in the sense which one, T1. So C in the sense D3. So this one VBC. So VBC in the sense T2. You only have to see that when B is there. So to B, which thyristor is connected? To B2 is connected. So T2. C. So for C, which diode is connected? So D3. Then VBA. So for B, T2 is connected. So A in the sense which diode? D1. A very simple thing. So VCA for C which thyristor? 3, third thyristor. So T3. So for A, D1. So VCB, T3. So T3, B is D2. So D2. VAB once again T1, D2. So it is also T3, D2. So likewise, you know yourself that which diode, which thyristors are conducting. That's very simple thing. So now you see here yourself that when alpha greater than 0, so I will erase this here, it's not alpha 0, is alpha greater than 0. Okay. So when alpha is greater than 0, I will write here alpha is greater than 0. So when alpha is greater than the triggering will not occur exactly at 30. So you will find out that so this value will be continued. This value will be continued. So how it will be? So it will be delayed. I will say this thing that it will be delayed. Yeah, yeah. You see here. So here T1, here also T1. Now the T2. I will erase. I will erase this part. You must understand why I am erasing this part. Why I am erasing this part is that only thing is that so both these are AA, whereas both these are BB. Then next one is C. So C, C, C. Then once again AA. Now you see here. So there is a gap I have given here. This. So at this instance, you trigger thyristors 1, 2, 3 respectively. So if you don't trigger, then there will be gap here. So in this gap, what will happen? That is the question. So what will happen in this gap is that, what exactly will happen in this gap is that, as it is continuous conduction, if you take, now this continuous conduction will be there. So why the continuous conduction will be there is that, or discontinuous conduction? You must understand this thing, that which one will be there. Okay. So what you will find out here is that your VCB is there, as this inductor is there, inductor current is there. So in this small duration, the small duration which I have given here, alpha. Okay. this small duration, one important thing you will find out. What is the thing is that, okay, so you did not turn on thyristor 1 here, then the thyristor 1 is on, then thyristor is still conducting. Now, after this point, you will find out that the current will be there, but the output voltage, you will find out something like this. The output voltage will be, okay, so you imagine yourself that what will happen at beyond 150. So beyond 150, the highest one is this, okay, so VBC, so VBC. So you will force that one to become 0. So this is what exactly happens in this case. Because why I'm saying is that the output voltage, what will happen when the thyristors 1 and when the thyristors T3 D2 are conducting. So T3 is here, D2 is conducting. So when they are conducting, okay, when they are conducting, you will find out this thing. So during this freewheeling diode, as there is a freewheeling diode is there, and you find out this is negative, then you'll find out this thing. What you will find out is that this you will find out. You see here, this important thing you will find out here. So only thing is that what will happen in this small duration when you don't trigger, and when you don't trigger, so it means at this point you are not triggering anything. So when you don't trigger, so it means, for example, VAC is there. So at VAC, that is in this duration, A is higher and the least one is C. So VAC are conducting. So B cannot conduct even though you trigger. Then what will happen at the end of 150? So at the end of 150, your way A becomes lower. So when A becomes lower, then across this you will find out when A becomes lower, so B is higher. Then if you trigger this, assume that you are still trigger this, then what you find out is that as you don't trigger B, as you don't trigger yet, you are not triggering B. So when you don't trigger B, then what you find out is that A is still conducting. So when A is still conducting, then you will find out this thing that B, you are giving some delay. So when you give delay, then you will find out like this. So suddenly it will increase like this. Here also suddenly it will increase like this. Here also suddenly it will increase like this. Here also suddenly it will increase like this. So this step you will find out. So this extension will be there. You see the extension here. So this you will find out. This you will find out when alpha greater than 0. Say for example, I will take one value, alpha is equal to 60 degrees. So this I am interested to know what will happen if I take alpha 60 degrees. Alpha 60 degrees in the sense from 30 to 60, that is 90 degrees. So this delay will be continued till 90 degrees. This is what will happen. Okay. So now we'll do one thing. Yeah. See, I hope you got this already in power electronics course, that what will happen if you delay. If you delay, what will happen? That okay, then yeah, just okay. So now I am taking here VA for alpha is equal to 60 degrees exactly. So in that case, what will happen? We'll see now. So nothing, just this delay which is there here, it will extend. this delay will be extended. So now you see here, this delay is there, that is alpha I have taken greater than 0, you can take 10 or 20 degrees. But if I take alpha is equal to 60, so I will just show you how. Yeah, just check now. So now this time alpha is equal to 60. I'm writing, okay. Alpha is equal to 60. Alpha is equal to 60. So alpha is equal to 60. This delay is there. So whichever delay, so this will delay till 60. So when it delays till 60, what do you find out is that, so this part will be completely erased. Why it will be complete? Because 60 degrees delay in the sense, or a 60 degrees fine angle in the sense, this point is 30. So this point is 90. So this 30 will extend till 60. So this delay, I hope you can understand this, what I'm saying, that, yeah, it will continue like this. It will continue like this. Then after that, it will jump suddenly to this point. You see here. Once again, here I will erase this part. Now this T1, D2 will not be there. Let me erase this. To avoid confusion here, I will erase this part here. So now you see once again that, so this delay will continue till this point for alpha 60. So once again, now this T3, D1 will not be there. Okay, it's very simple to understand. There is nothing else is there if you follow these graphs. See here, earlier when alpha is 0, there is no delay. But when you increase alpha, so this graph slowly coming down. So that what you'll understand. So this graph is slowly coming down. So now when this value is 60, then so this delay will be 60. So this graph will come for 60 degrees. For 60 degrees in the sense from 30 to 60. So from 30 to 90. So this is 30, this is 90. So between difference is 60. So alpha is also 60. So it will delay like this. So the pulses you see here, the pulses become single now. This is for alpha is equal to 60. Now I will take alpha is equal to, now I will take alpha is equal to 90. I will take. So if I take alpha is equal to 90, okay, if I take alpha is equal to 90, what will happen in that case? So one thing I will tell, yeah, I'll bring this here once again. Yeah, so for alpha is equal to 90, I will draw now. So for alpha is equal to 90, this, you know, this is 30, this is 90, okay, and 30, 90, whereas this point is 150, this point is 210. Yeah, so alpha is equal to 90 in this is what you find out is that from 30 to 90, that is 120. So till this point, delay will be till this point. So till this point, what you have to do is you erase everything. You erase everything. So if you erase everything, what you find out is that this part will not be there. Okay. So this graph will continue till 90. Then after that, it will become 0. So the output voltage becomes 0 here. You see now. When the delay is so high, that is more exactly 90, then you will find out this much. So it jumps like this. So this from 90 to 120, from 90 to 120, you see yourself, the output voltage is 0. This is what you have to understand. Similarly, let me complete this also. What do you find out is that, yeah, then here 0, 210 to 240, then it will jump suddenly. So during this, what, there is one important thing, what will happen during this? During this, from 90 to 120, the output voltage is 0. So output voltage is 0 in the sense, you see yourself, the freewheeling diode is conducting. So because output voltage is 0, when it is so, because the freewheeling diode will conduct. So here the freewheeling diode will conduct. Here also the freewheeling diode will conduct. So this is how it flows. This is how it flows. So so I have drawn this for alpha is equal to 90 degrees. Let me check. Let me correct this here, 90 degrees. So alpha is equal to 0, alpha greater than 0. Then once you go on increase the value of alpha, you will find out the output voltage will be delayed. So this delay, if you go on increase alpha more and more, then this delay will be more. At one point, that is when alpha is equal to 90 degrees, you see yourself that there is a break is there in the output voltage. In that break, what do you find out is that uh, the freewheeling diode will conduct. So when the freewheeling diode is conducting, okay, then that's it. So this is you will find out here. Now say for example, okay. So one more case I will take here. For example, if I take alpha is equal to 120, if I take alpha is equal to 120. So if I take alpha is equal to 120, what will happen if I take alpha is equal to 120? So now, till alpha is equal to 90, you can assume that the conduction is continuous. So because at least freewheeling diode is conducting, so the current in the inductor is always there. Either the thyristors are conducting or freewheeling diode is conducting. So the current is always there. The current is always there. But now if you take alpha is equal to 120, say for example more than 90, if you take, so I will write here more than 90, alpha is greater than 90, or you can take one example, alpha is equal to 20. So if you take this case, what will happen? What will happen? Yeah, you see yourself what will happen if you take alpha is equal to 120. So alpha is equal to 120 in the sense, just see yourself, this is 30. So from 30 to 120, so it means 150. So here, so you'll find out the delay till 150. So if you find out the delay till 150, you simply erase all these parts, because alpha. So in this case, what you find out is that this black color, I will show you here now the black color. So this waveform will become 0 here, and after that it will become 0. It means it will become 0 in the sense, freewheeling diode will conduct. So once the freewheeling diode is conducting, now the energy in the inductor may become 0. So if the energy in the inductor becomes 0 at this, say assume that it's 0, then in that case, in this case, that is alpha is equal to 0, IA value will become 0. See here, thyristor conduction is over, then freewheeling diode conduction is also over. If you further increase the value of alpha, then this freewheeling diode conduction is also over. Then the current in the armature will automatically become 0. If the current in the armature becomes 0, then what is the VA value? If you apply KVL here, if the current is 0, then VA is equal to EB. This you have seen even in the single phase converters also. Then what do you find out is that, so you will find out this thing, that the voltage after this point it becomes EB. So this is EB. Now after at 150, once again you trigger another set of thyristor. So it becomes now this. So once again, so this will continue further. So 150. So this will be there, then you have this, then so this EB is there, this part is EB, whereas this part is freewheeling diode. So this part is freewheeling diode. So the remaining so this is the Waveform. So you see the waveform how it changes from alpha is equal to 0. This is for alpha is equal to 0. This is alpha. Sorry, this is alpha greater than 0. The first one is alpha is equal to 0. This is alpha greater than 0. Greater than 0 in this is small value, just 10 degrees or 15 degrees something. Whereas this is alpha is equal to 60. This waveform is alpha is equal to 90. And this waveform is alpha is equal to 120. See the differences here. When alpha is equal to 0, you will see that exact loops you will get here. Whereas when alpha greater than 0, there is a small delay. If you increase the value of alpha is equal to 60 degrees, then the voltage it touches 0. It touches 0. When alpha is equal to 90, so it touches 0 and some duration it maintains 0. So during that duration, freewheeling diode conducts. When alpha is still greater than 90, say for example alpha is equal to 120, then freewheeling diode conduction also stops. Then the total current in the armature will become 0. So when it is 0, then the output voltage is same as the back EMF. So this is how when you increase the value of alpha, this is the output voltage for different values of alpha. This is the output voltage. Okay. So now once we understand this briefly, then what we are going to do is that what is the average voltage, VA average? How do you find out VA average? Say for example, the firing angle is alpha. So if the firing angle is alpha, then that case we will take. Which one? Yeah, this case. This case we will take. We will take this case. So if you take this case, okay, then you see yourself. What you will find out here is that yeah, this derivation I'm sure that we have already done this derivation in case of the power electronics, but anyhow we'll try once again here itself. That what do you find out here is that, for example, you take VAC is there, say for example VAC is there. So if you take VAC, then what do you find out is that for, so what is the time period here? The time period here is that you take 60 degrees is the time period. Okay, because you see yourself the time period is simply 60 degrees. So 1 by 60 degrees, no, sorry, it is not 60, it is 120 degrees. I'm sorry for that. Okay, just check this yourself. Check this yourself. The time period here is, you see here, 120. Okay, so it is 120. So 120 time period you will find out. So 1 by 120 in the sense 2 pi by 3 integration 30 plus alpha, because I told you already alpha in the sense you have to start from 30, this point. This point now, this point. What is this point actually? This point is 30. So 30. So the alpha will start. So the alpha is equal to 0 means 30. So 150 plus alpha, because 120 degrees duration. Then you will find out VA minus VC d of omega t. So for that duration, the output voltage is VA minus VC from 30 plus. So this you will see from the waveform itself. Then in that case, if you do the simplification, see I'm not going to do the simplification. So VA minus VC, I will get here a line voltage. So that line voltage I will write directly here, 3 root 6 into line voltage divided by 2 pi into 1 plus cos alpha. This you will get here. I want you to check this. Okay, so that you will know yourself what will happen here. Okay. Okay. So see this, please do the derivation, because VA, VC in the sense you see here. What is VA is that, see, let me tell you, VA in the sense VAN. I will write here. VAN, VCN. So you know the waveforms of VAN, VCN. You see here. This is VAN, this is VCN. Substitute there in this duration, then you must get this answer. You must get this answer. Okay. And then what else you will find out is that this is VA. So as you know already, VA is equal to EB plus IA RA. EB plus IA RA. Then what you will find out here is that, so EB as EB back EMF in this case back EMF is that some K into N, because this is separately excited DC motor. So the values are simple thing, that the values are 0. Okay, as the values are 0. Okay, as the values are 0 here, So you will find out this thing that substitute this here. VA is equal to Kn plus IA RA. And one more thing is the torque expression you recall is some constant K1 or K2. So if you take this as K1, this is K2, then IA, because this is separately excited DC motor. So using these two, substitute this here. VA is 3 root 6 VL by 2 pi into 1 plus cos alpha. I want you to cross check this. I want you to cross check this. Okay, just cross check this. So that is equal to K1N plus, so you write T by K2 into RE. So we'll get this answer. So once we get this answer, okay, so we can go ahead with this, and we'll find out ourselves. So this is VA, this is VA, okay. So now we can draw the torque speed characteristics. See, torque speed characteristics, I'm sure that they are very same as the single phase case. Whichever the single phase case, the torque speed characteristics you got, here also you will get the same. Only the magnitude may vary. The magnitudes may vary. Okay, the graph something like this you will get here. This is what the graph you got, I'm sure. Alpha is equal to 0, alpha is equal to 30. This is the graph you got between speed and torque. Okay, so whereas if you draw the output voltage with alpha, that is this expression, then alpha is equal to 0 as the highest value, then after that it will decrease. So something like this you will get here. So this is alpha is equal to pi, alpha is equal to 0. So this is how you got, this graph is for this equation, whereas for this equation this is the graph. So this graphs already you got even in case of the single phase case also. So that's the reason that I did not explain more about this. Okay, so now this is speed torque characteristics and also the relationship between voltage and firing angle. Okay, so then what we will do is that we will see so we will see now whether this is correct or not. Okay, so VAC is nothing but so line voltage. So yeah, I want you to check this yourself that whether it is correct or not. Okay, line voltage and phase voltage, so both are there here. Okay, so now for just I'm sure that this is correct. Just check yourself. This is already I have verified this thing. Okay, so this is the average output voltage and this is the speed torque characteristics, whereas this is the relationship between output voltage and the firing angle. Okay,